Okay, so I'm re-recording this video in summer 2022 because the Rossman Chance applet has changed and it's not working quite as well. I'll make that other video available too in case they ever fix it. But um, what happens is when you copy paste the data into the applet, it gives you erroneous results. Okay, so the best way to deal with this is to calculate the means and standard deviation separately. So I'm gonna just copy this to my clipboard memory. Because I don't want to have to calculate the means and everything by hands. So I'm gonna go to a spreadsheet. I'm gonna paste them in. Okay, so then I'm gonna calculate some means and standard deviations. So the mean, remember on the spreadsheet, we do average. You can use some other applet to give you the mean and the standard deviation if you want. So that's the mean for the SAT, mean SAT score for people that studied music. And for the standard deviation, I'm going to do a similar thing, equals STD. Here, it pops right up here. Yeah, I want this one. Did it remember it? Whoops. Well, let's see what it did. It's just getting too smart. So now I'm going to do the same thing for with music or no, without music. And I'm just using see how it did that. You can retype everything or it'll do it for you if you just fill over. So now what I'm going to do is, let's see, I see there's 8 people. Let's see. And there's 8 people that study music and oh no, that's not true. Yeah, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, and then 1, 2, 3, 4, 8, 9, 10, 11. Then 11 people who didn't study music in their test scores. So now I'm going to go to Rossman Chance. Let's see, where is that? Right here, theory-based applet. And instead of having to do all those calculations, let's see here. Let's not have people's grades up there. I want this and I want this. Here we go. So to use this Rossman Chance applet for this kind of sample, now this is 2 independent samples. These SAT scores are not the same people. Like these are different people. I mean, one person studied music got a math SAT score of 521. A different person who didn't study music had a math SAT score of 480. Unlike a matched pairs when they're same person, 2 different scores, right? For hope before or after. That's a matched pair situation. So don't do that. So I've got 2 means. I'm not going to paste in the data. I'm going to let use these spreadsheets calculated values. I might, as part of this video at the end of it, paste it in just to see how close they are. Um, so the mean for with music is 562.125, and the sample standard deviation is 30.17 because it's myopic math. I'll put in some more decimal places. And then there's 11 people who did not study music, and they had a mean SAT score of 523, and their standard deviation is 35.5087. I'll use. Okay. Bigger spread, smaller mean, bigger spread. So then we're going to say we were trying to test to see if, yes, the claim was that, let's see, let's go make sure I'm looking at the right claim. Is this set? Oh, it popped up in a separate window, didn't it? Here it is. We want to test the claim that students who studied music in high school have a higher SAT. So mu1 is greater than mu2, or mu1 minus mu2 is positive, right? So we're going to come back here to that Rossman Chance applet. If I can find the foolish thing, here we go. I'm going to click a right-tailed test, calculate, and we had standardized test statistic at 2.74, a very small p-value. So remember, this is our test statistic, very small p-value. Let's see. So this is a right-tailed test. My test statistic is what did I say it was? I just want to see if I get this right, see how it agrees. 2.7, 2.74. Sometimes it doesn't give us enough decimal places, but I think it's going to this time. Our p-value is 0.0074, 0.0074, and we're gonna reject HO, very small p-value. The data supports the claim that yeah, just like that. So that's how that goes. And I just want to click this and let's submit for testing and see what happens if it liked what I gave it. Oh yes, it was out of 5 points. Did. Okay, now if you're having trouble with the claim, well, let's see. Maybe I shouldn't go there yet. I do want to go see. So that's how you use this applet to get these two sample tests right for WebAssign. Okay, it hasn't been liking the copy paste stuff. So let me stop it. I'm going to go back in and test it and see if it's worth recording for you to see what, if you just copy paste it, see what happens. So I just did the straight copy paste in, and it did give us a different, it wasn't much different. What was the correct one? It said 2.74, and doing the copy paste method, it only said 2.44. P-value is a whole lot bigger too. Okay, so that's when I pasted in. So something I'm going to do is to explore to see if it's working. I pasted the smaller set of data on the left. Maybe we should try putting the, because what I did, I'll show you why I'm thinking this. I don't know if this is going to work. See, when the basic default data has the bigger group in the left-hand column. So let me come back here. Let me clear this out. I guess I'll just keep recording this through. I'm gonna grab this, paste that in there. Then I'm gonna grab that data. See, that's just the data, right? Control C. Back to Rossman chance. Let's see if this works. Paste this in. Use the data. Whoops, I got to go right-tailed. Oh, no, actually, I got to go left-tailed now, don't I? Oh, not two-tailed, left-tailed. What's that do? So 2.74. Okay, and 0.0074. That looks like what see what was the real, okay, so that does give us the right answer, except it's reversed, right? Because we were trying to, the claim is greater that the people with music have a higher average than the people without music, that SAT average without music, that they didn't study music, and it's given us the right values. It's just that the z-score is reversed to what WebAssign is looking for. Okay, so it does do it for the pasting it in, but you got to make sure, you got to think, okay, I'm reversing it, and I'm going to change that sign. You get the bigger data on the left, and it depends on the situation too. I hope you see the easiest way to do this is just calculate the mean and the standard deviation separately, and then use a calculator. And it's much easier. If you have a TI graphing calculator, it does it fine. You can just put it in your two stat lists, but you don't want to buy one of those. I mean, if you have one and you want to learn how to use it, give me a yell. I probably get a video on it, or other people do. So, all right. Hopefully this helps.